We're now going to look at continuous compounding, which is a continuation of the compound interest that we had prior. Anytime you see the word continuous, it means this formula right here, A equals P times E raised to the RT. Now the A, the P, the R, and the T are values that we have seen before. E is a numerical base. It is actually that right there. And the nice thing about this, what happens is that this works with anything that is continuously growing or continuously decaying. But we're going to be looking at money, okay? So that means our money here is going to be getting interest every second or millisecond, okay? So I also call this the shampoo formula, if anybody knows what PERT is. Some examples. If $23,000 is invested at 13.5% compounded continuously, what is the amount after 15 years? In order for me to use that formula, I have to have that word. So this is the formula I'm going to be using, putting the values in the appropriate position like we've done before. I'm going to have A equals 23,000 times E raised to the 0.135 times 15. Okay, so go into my calculator. I can do all of this at one time. Notice right above LN, I have an E to the X. For me to access it, it's color coordinated. And if you'll notice, it's got E and a caret symbol and a parentheses. So all I have to do is type these values in. 0.135 times 15. So 23,000 grows to that at that interest rate for 15 years. It's a one-time deposit. I doubt if you'll ever find anything like that at that interest rate. But if there was such a thing, that's how much that money would grow. Now remember, I can find out how much interest if I take the amount minus the original investment. Not bad. Not bad at all. But that is if you can find something like that. Alright, the next problem. If an investment earns 12% compounded continuously, how much should you deposit now to have $4,800? First problem is 48 months from now. The second one is 7 years from now. But now look and read the question again. I've got this investment. It says how much should you deposit? That is your principal. I don't know the P. They do have continuous, so I've got to use that formula. The 4,800 would go here, interest rate 0.12, and 48 months, remember T is time in years, so that would be 4. So let's see what I've got. Okay, now I can do this all at once in my calculator. E raised to that exponent is a number. So if I want to find out P, and since that number is multiplying P, I'm going to divide both sides by that. So 4,800 divide by second ln. I'll put my 0.12 times 4 in the parentheses. And we should deposit that much if we want 4,800 in 4 years. Okay? 7 years from now, well, still under continuous compounding. Only change is that 7 goes here. So let's see how much we have to invest. Notice the only difference is my number of years. So if I do that, let me do a second enter, because the only change is going to be my time. So I only have to do that amount. But guys, notice it's in there for for 3 more years over that. So me putting in less would make sense. Okay? The other thing in this particular section, we look at effective rate or annual percentage yield, shortened to APY. And that is the simple interest that would produce the same returns in 1 year if the same principal had been invested at simple interest without compounding. Now, why we have this is so that we can compare different investment opportunities that have different interest rates and different compounding periods to see what might be better. Now, the first one I have is just for compound interest, and you only look at $1. Just look at $1, because what happens to $1 would be the same effect as if I had $10, $100, or $1,000, because I'm going to be subtracting out that original investment to find the APY. So my interest rate, my N, and here's my compounding period. Now remember, this is for 1 year, so this is all I need. Now this one is if I had continuous compounding, and all I'd have to have, since my p-value would be $1 and the t would be $1, all I have left from that formula is just e to the r. So some more formulas to add to your collection. So in this example, which is the better investment and why? 10% compounded monthly or 10.2% compounded semi-annually. This one's being compounded more than this one, but this is a higher interest. So let's see. So the first thing I'm going to do is put everything where it needs to go. Whoa, it jumped on me. In my formula. So I'm using this one because I do not see anything said about continuous. And if I put all of that in my calculator, I don't know why it's doing that. Irritating. So I come up with that and keep every single one. I think I'll just move these. So in the second one, the 10.2%, I put everything in the appropriate position. Compounded semi-annually, remember that means n equals 2. Monthly is 12. And if we put that in, we come up with that. Now if you compare the two, you have to go all the way to the 4th decimal position to see which one is better. And this one over here would be my better investment because the APY is better. I'm going to delete these. Oh, now it's not jumping. Lovely. Okay, that's it for this one. Thank you.